Hey everyone, in notes number 3, we're going to be taking a look at a shortcut to finding the distance between a pair of points. In this first box, it says, what is the distance between points A at 11, 2, so an x value of 11, y value of 2, and point B at 5, 10. Again, we're given an x and a y. And it says, what is the mistake? Well, if you take a look here, the mistake happens with the way they have lined up the points. They put 11 and 2 vertically instead of horizontally. So ideally the table really should say, with our x and y at the top, 11 and 2 and 5 and 10. So the x's go in the first column, y is in the second column. Alright, continuing on, it says, what is the distance between those 2 points, A and B? Now keep in mind that point B being at 5, 10 might look something like that, and point A at 11, 2 would be down and to the right. And notice that if we draw that line segment, when we go to find the length, by turning this into a right triangle, the change in x is 6, because we're going from 5 to 11, and the change in y, you could say, is negative 8. But remember that distance is positive. So ideally, instead of using negative 8 in this problem, we could use positive 8, or we could just remember that we really need to put the negative 8 in parentheses, because in the Pythagorean theorem, it would be the length of that side squared plus the length of the other side squared equal to our hypotenuse. Okay, I'm going to make a transition here. We're going to start to call that distance d, just so we get used to saying that that's the distance. And when we use the distance formula, it's in the form d equals. So negative 8 squared is 64. Positive 6 squared is 36. And that's actually equal to d squared. 64 and 36 is 100. So to finish solving it, we need to take the square root of 100 and the square root of d squared. And that gives us our distance d is equal to 10. Alright, let's scoot this up a little bit. And it says just set up the tables for these points. So we'll just do a little xy table for each. Really quick, it's going to go 3, 2. Remember x, y, 9, and 6. Likewise, the next one goes 7, 1, and 11, 2. And finally, the last one with x and y go negative 2, 3, 1, negative 5. So all along, we've been finding the distance by doing the change in the x's, like x2 minus x1 quantity squared, plus the change in the y's, y2 minus y1 quantity squared, is equal to the hypotenuse squared, or d squared. So now, if we just want to use the distance formula, where d is alone, we get there by taking the square root of both sides of this. Okay, so the distance formula is a really useful formula. It's our shortcut. So we don't have to draw triangles anymore. We don't have to label the sides. Technically, we're still using the Pythagorean theorem, but I think you'll find the distance formula pretty easy. You might first want to label your points x1 and y1. The 1s are just for the first point, x2 and y2 for the second point. To set it up, d is equal to the square root. Take and subtract your x's, so do 3 minus 5, quantity squared, plus, and then in parentheses do 4 minus 7, quantity squared. Okay, remember, if you get a negative, just keep it in parentheses. 3 minus 5 is negative 2 squared. 4 minus 7 is negative 3 squared. Now negative 2 squared means negative 2 times negative 2, so it's positive 4. Negative 3 squared is negative 3 times negative 3, so it's positive 9. to get a distance equal to the square root of 13. So that's it as a radical, but then we can approximate it to the nearest tenth. Okay, so a couple things to watch out for. Most commonly, mistakes are made here. People forget the plus sign in between and with the subtraction. I want to show you something really quick. It wouldn't matter if we did the x's and y's in a different order. If I did 5 minus 3 quantity squared plus 7 minus 4 quantity squared, we still come out with the same answer. Because 5 minus 3 gives us 2 squared. Now I don't need the parentheses because it's positive. And 7 minus 4 is positive 3 squared. Still going to give us 4 plus 9 inside there, which is still the square root of 13. Okay, so the reason why I did it this way was to show you that it doesn't really matter which point you choose as your first point and your second point. So if you notice that it would be easier to use the x's and y's in a different order, then I say go for it. Okay, number 2, the distance between those points, we'll do d equals the square root, parentheses, this is x1, y1, x2, y2. So take 5 minus a negative 5, quantity squared, plus 2 minus 7, quantity squared. So d is equal to 10, because subtracting a negative is the same as adding a positive. So we've got 10 squared plus negative 5 squared, because 2 minus 7 is negative 5. Watch that negative. 10 squared is 100. Negative 5 squared is 25. So d is equal to the square root of 125. Okay, you can leave it as a radical. We'll talk about simplifying radicals later this year. And it's also okay for now if you give this to me as a decimal, as long as it's rounded to the nearest tenth, 11.2. Okay, a couple more to try. We've got x1, y1 in number 3, x2, y2. So d is equal to the square root. I'm going to take negative 4 minus that negative 8, quantity squared, plus negative 9 minus a negative 1. Okay, there are negatives all over the place here, so be careful. Negative 4 minus that negative 8 is going to turn into negative 4 plus 8. So that's going to become positive 4 that we're going to square. Negative 9 minus a negative 1 turns into negative 9 plus 1, which will give us negative 8 quantity squared. 4 squared is 16. 4 times 4 is 16. Negative 8 squared, remember you're doing negative 8 times negative 8, so it's positive 64. Add those two together to get the square root of 80. And as a decimal, it would be approximately 8.9. And finally, in number 4, we've got x1, y1, x2, y2. So this will give us 2 minus a negative 4 quantity squared plus 3 minus a negative 8 quantity squared. Okay, watch that subtraction. 2 minus a negative 4 turns to 2 plus 4, so that's 6 squared. 3 minus a negative 8 turns to 3 plus 8, and that's 11 squared. So we have d is equal to the square root of 36 plus 121. That gives us d is equal to the square root of 157. Okay, which as a decimal would be approximately 12.5. Anytime we're rounding, that's why I'm using these wavy equal signs, because that's an approximation. Okay. All right, good luck on homework number 3. And always know that you can email me with your questions or stop in and see me for extra help.